into the hormones topic and comes into the nerves topic, is this concept of gated channels. Now, embedded within your membrane, you have channels for all kinds of things, and in nerves and in hormones, we talk about potassium, sodium, and calcium channels. Now, these channels are what's called gated. Now, they can be opened or closed depending on a specific stimulus. So one of the ones you'll come across in the hormones topic is ATP gated channels. Now what that means is that when ATP binds to this channel, it will cause it to close. And you find that in insulin, these potassium gated channels, when ATP binds to it, it makes the channel close. Now some of the others are what's called voltage gated channels, so we're going to talk about that. Now, voltage is the same as potential difference. Physicists would argue, but for the sake of this, we'll go with voltage and potential difference being interchangeable. So, if you think about a membrane, you've got inside a cell, you've got outside a cell. Now, we can accumulate ions on one side and fewer ions on the other side. And you see this with nerves and you see it in the hormones topic with the release of insulin. Now, if you have more positive ions than on one side than you do on the other side, then it stands to reason that this is more positive. And so this side would then be less positive. Now, that's a little bit cumbersome, talking about more positive and less positive. So what we do is we talk about the difference across it. So relative to this side could actually be considered as being negative relative to this. Okay? So because you've got more positive ions there and fewer positive ions there, this can be considered negative in relation to this side. Okay? So that's the potential difference. Now, with nerves and with insulin release, that difference can be measured in millivolts, and at rest, in both cases, it is minus 70 millivolts. Now, what that means is there is a 70 millivolt difference across that membrane. Okay? Now, sometimes you can get an accumulation of these ions on one side or another. You've got this potential difference, you've got this difference across the membrane, and so these channels will either be open or closed in that state. Now, there are various things that can happen that will change that. For example, if I draw another kind of a gate here, and if we say under these circumstances, where that is positive and this is negative, these ones are open and these ones are closed. If these are open and these ions are able to move through there, then you're going to start to get an accumulation of those ions on this side. Now what that might do is if it's positive on this side and then negative on this side, that potential difference might actually then stimulate this one to close. So under these circumstances where you've got more positives on this side now, then that gated channel might close in that voltage kind of condition. Okay? Now, if you get that change, the gates that were closed might then be stimulated to open, and some other ions, or the same ions, might then leave. So you can get this change. You can get ions swapping, but these gates will change. They will open or close dependent on the potential difference, dependent on this voltage across the membrane. And so some of them will be closed if it's more positive on this side, some of them will be open if it's more positive on this side, and vice versa. Okay, so it's a concept we talk about a lot in nerves, and it comes up in hormone. But it's this idea that these channels will open or close in response to a potential difference across a membrane. So sometimes, if you've got this minus 70, some of these channels will be open. Other channels will be closed under those conditions. If you get this swapping, and so you get some of these ions coming here, this potential difference might go up to -30. It might go all the way up to +40. So you've got an awful lot in these conditions. You've got an awful lot more on this side than on this side. And these channels might then reverse. So if these ones were open and these ones were closed, these ones will close and then these ones will open. So essentially, all it is that you have more ions on one side than another, so you have a potential difference. And in those circumstances, in that situation, some channels might be closed, some channels might be open. If you swap that, if you move it, if more ions move in, for example, then the channels that were open may close, the channels that were closed may open. So they open or close dependent on the potential difference, dependent on the voltage. And that's why they are called voltage gated channels. Because they're gated, they can open or close, dependent on the voltage. If it's -70 millivolts, if it's +40 millivolts. Okay?